Welcome to all. This is EMERTXE Training Institute internship project on embedded system. Myself Jagat, pursuing BE Agri Engineering in Excel Engineering College at Komrabalayam in the district of Namakkal from Tamil Nadu. Before getting into the project, we shall view the basics of embedded and detailed specific view of microcontroller which it was used in my project. Introduction for embedded system. An embedded system is a microprocessor based computer hardware system with software that is designed to perform a dedicated function either as an independent system or as a part of a large system. At the core is an integrated circuit designed to carry out computation for real time operations. How an embedded system works. Embedded systems are managed by microcontrollers or digital signal processor DSP, application specific integrated circuit ASIC, field programmable gate array FPGA, GPU technologies and gate arrays. These processing systems are integrated with components dedicated to handling electric and or mechanical interfacing. Types of embedded system. First one is standalone embedded system, and second thing is real-time embedded system. Third thing is network or networked embedded system, and fourth one is mobile embedded system. What is mean by standalone embedded system? The standalone embedded system does not require a host system like a computer or a processor, as it works by itself. Analog or digital signals and processing is alone in the port itself. Real-time embedded system. When an output is required at a particular time, real-time embedded system can be used when a task has to be completed on time or deadline for a project. These systems comes as a savior. There are two types under this category: soft embedded system and a hard embedded system. Networked embedded system. When a program is running inside another device, a network is formed. This is called networked embedded system. All the network is controlled and accessed with the help of web browser. And finally, the mobile embedded system is all the devices that are portable and working with the embedded system is a mobile embedded system. Best example: mobile phones, laptops, and calculators, etc. Based on performance, the microcontrollers classified into small scale embedded system, medium scale embedded system, and sophisticated embedded system. Components for embedded system. First thing is ALU, arithmetic logic unit, and second is timer and interrupt. Third is RAM. Fourth, ROM. Fifth is OSC, that means oscillator. Sixth one is analog to digital converter and digital to analog converter. Seventh is actuators. Eighth thing is sensors. ALU, arithmetic logic and control circuits. The ALU carries out basic arithmetic and logic generations, and control section determines the sequence of operations, including branch instruction that transform control from one part of a program to another. ROM, RAM, and timer interrupts we will see in this coming slides. And we go into the OSC, means oscillators. The clock oscillators are the pillars of electrical engineering, and then components play a vital role in devices such as central processing unit, communication buses, tone generators, frequency synthesizers, RF systems, and peripherals. And now we're going to see of the seventh, actuators. An actuators is a device that moves to control some mechanism. And actuators turns a control signal into mechanical action such as an electric motor. Finally, we are going to see about the sensors. A sensor is a device that detects and responds to some type of input from physical environment, example light, heat, moisture, pressure, etc. Difference between microprocessor and microcontroller unit. First, we are going to see about the applications of microprocessor, which it is the microprocessors are used for gaming, web browsing, document creation, etc. At the same time, the microcontroller is used for dedicated to done a specific task. The cost wise, the microprocessor is high and microcontroller is very low cost. Uh, by internal internal structures of microprocessor is memory and input and output devices connected externally. But the MCU, microcontroller unit, The CPU, memory, and input output ports are present internally. RAM. The RAM stands for Random Access Memory, which temporarily stores data while the control processing unit CPU is executing other tasks. There is a two types of RAM. One is the SRAM and DRAM. SRAM. It is made up of 4 to 6 transistors. It keeps data in the memory as long as power is supplied to the system. But the SRAM is faster but also more expensive. DRAM. It is widely used as a computer's main memory. Each DRAM memory cell is made up of a transistor and a capacitor within a integrated circuits, and a data bit is stored in a capacitor. ROM. ROM stores firmware, which is permanent software that hardwired with integrated circuit. The manufacturer fits specifically designed ROM chip into a device during the building process. Types of ROM. Random access ROM read-only memory, and PROM programmable read-only memory, EPROM erasable programmable read-only memory, WPROM electrically erasable programmable read-only memory. What is meant by embedded system? Where it was used? Almost every electronic gadget around us in an embedded system. Digital watches, MP3 players, washing machine, security systems, scanner, printer, cellular phones, elevators, ATM, vendor machines, GPS, traffic lights, remote control, microwave oven, and many more things are come under in the embedded system. And we are getting into the project, and our project topic is car black box. What is mean by car black box? The stated purpose of the black box in your car is to prevent future crashes, just like with aeroplanes. The black box depicts data such as how fast your car was going, the position of the throttle, brake application, airbag deployment, seat belt use, steering angles, and a range of other factors, as they were about 20 seconds before, during, and 20 seconds after the crash. Collecting this information can help the vehicle manufacturer know if the crash was caused by a preventable human error or a mechanical failure in their system. These are the topics I learned and implemented during this internship. The first one is PIC16F877A microcontroller unit. Second thing is PIC timer and interrupt. Third is interfacing and programming a CLCD in PIC. Interfacing and programming a digital keypad in PIC. Inter-integrated circuit with PIC. Real-time clock in PIC. And WP-ROM in PIC. In PIC16F877A, it has 5 input-output ports, namely port A, port B, port C, port D, port E. In port A, it has a 6-bit wide, and port B, it is a 8-bit wide, and port C, it is a 8-bit wide, port D is a 3-bit wide. And also in PIC16F877A, it has a 3 timer module. What is meant by timer and interrupt? The timer is an important application in embedded system. It maintains the timing of an operation in sync with the system clock or an external clock. The timer has so many applications such as measures time generating delays. They can also be used for generating baud rates. A normal delay function might be used for loop, iterating for a few thousand cycles. But these types of delays need to be accurate, and fundamentally it is not a good programming practice. So timer or counter is a software designed to count the time interval between events. It counts the cycle of the peripheral clocks or an externally supplied clock. In PIC16F877A, timer 0 is a 8-bit timer or counter, and timer 1 is a 16-bit timer or counter, and timer 2 is a 8-bit timer. Interrupt. Interrupt can originate from both MCU internal and MCU external device. An interrupt from an external switch or sensor, for example, is sometimes called attached interrupt, as it is generated by an external device that is attached to an IRQ interrupt request pin on the microcontroller unit. When the relevant state change occurs, the external device sends an interrupt request signal to this pin, and this in turn generates a notification to the MCU's interrupt control. I2C. I2C stands for Inter-Integrated Circuit. It is a bus interface connection protocol incorporated into device for serial communication. It was originally designed by Philips Semiconductors in 1982. Recently, it was widely used protocol for short distance communication. It also known as two-wired interface (TWI). Working of I2C communication protocol. It uses only two bidirectional open drain lines for data communication called SDA and SCL. Both these lines are plugged high. Serial data SDA. Transfer of data takes place through this pin. Serial clock SCL. It carries the clock signal. I2C operates in two modes. First one is the master mode and second is the slave mode. Each data bit transferred on SDA lines is synchronized by high to the low pulse of each clock on the SCL line. EEPROM. EEPROM, electrically erasable programmable read-only memory, is user modifiable read-only memory that allows users to erase and reprogram stored data repeatedly in an application. In contrast to EEPROM chips, EEPROM memory does not need to be removed from the computer in order to modify the data. The term LCD stands for liquid crystal display. It is one kind of electronic display module used in an extensive range of applications like various circuits and devices like mobile phones, calculators, computers, TV sets, etc. These displays are mainly preferred to multi-segment light emitting diodes and 7 segments. The main benefits of using these modules are inexpensive, simply programmable animations, and there are no limitations for displaying custom characters, special and even animations, etc. The 16x2 LCD pinout is pin 1, ground or source pin. This is a ground pin of display used to connect the ground terminal of the microcontroller unit or power source. Pin 2, source pin or VCC. This is the voltage supply pin of the display used to connect the supply pin of the power source. Pin 3, control pin. This pin regulates the difference of the display used to connect a changeable port that can supply 0 to 5 volt. Pin 4, register select or control pin. This pin toggles among command or data register used to connect a microcontroller unit pin and obtains either 0 or 1. Pin 5, read and write. This pin toggles the display among the read or write operation, and it is connected to a microcontroller unit pin to get either 0 or 1. 0 is for write operation and 1 is for read operation. Pin 6, enable pin. This pin should be held high to execute read write process, and it is connected to the microcontroller unit and constantly held high. Up to pins 7 to 14, which it is called as a data pins. These pins are used to send data to the display. These pins are connected in 2-wire modes like 4-wire mode and 8-wire mode. In 4-wire mode, only 4 pins are connected to the microcontroller unit like 0 to 3. Whereas in 8-wire mode, 8 pins are connected to the microcontroller unit like 0 to 7. Pin 15. It is a positive pin of the LED. This pin is connected to 5 volt. Pin 16, negative pin of the LED. This pin is connected to the ground. Tactile switch. Tactile switch typically offers smaller package size than push button switches. Along with generally low voltage and current rating, their audio and haptic feedback is also a key differentiator compared to push buttons. And while push buttons offer panel or PCB mounting styles, tactile switches are only designed for direct PCB mounting. Basic structures. The first part of the tactile switch is switch cover, and second one is plunger. Third one is reaction spring, fourth one is base, and finally contacts or terminals. What is the switch bounce? When you push a button, press a micro switch or flip a toggle switch, two metal parts come together. For the user, it might seem that the contact is moved instantly. That is not quite correct. Inside the switch, there are moving parts. When you push the switch, it initially makes the contact with other metal part, but just in a brief split of a microsecond. Then it makes contact a little longer, and then again a little longer. In the end, the switch is fully closed. The switch is bouncing between in contact and not in contact. When the switch is closed, the two contacts actually separate and reconnect, typically 10 to 100 times over a period of about 1 millisecond. Usually, the hardware works faster than the bouncing, which result in that the hardware thinks you are pressing the switch several times. The hardware is often an integrated circuit. Real-time clock (RTC) is used to track the current time and date. It is generally used in computers, laptops, mobiles, embedded system, application device, etc. In many embedded systems, we need to put timestamp while logging data. In other words, sensor values, GPS coordinates, etc. For getting timestamp, we need to use RTC. Some microcontrollers like LPC2148, LPC1768, etc. have on-chip RTC, but in another microcontroller like PIC at 16 or 32, they do not have on-chip RTC, so we should use external RTC chip. There are different types of ICs used for RTC like DS1307, DS12C887, etc. In this slide, we will see DS1307. Timekeeper registers. The content of timekeeper register is in BCD, binary coded decimal value format. There are total 8 registers in timekeepers. Register for setting seconds, minutes, hours, days, date, month, year, and control. Once we set the value of these registers, they will keep updating themselves and we can read these registers to get updated value. Memory capacity of PIC16F877A microcontroller unit. First thing is flash memory, which size is 8K bytes, used to store the programs. And second thing is RAM. It has 368 bytes. It is temporary or scratchpad memory used during program execution. Third thing is WP-ROM, which it has the size of 256 bytes, used to store the non-volatile data across power cycles. These are the registers associated with PIC16F877A UART. The register EECON1, WP-ROM read or write control register, and EECON2 used to execute special instruction sequence during write. EE data holds the data to be written or read to form from WP-ROM. EE address holds the WP-ROM memory address from where the data needs to be read or written. Car black box using PIC16F877A. By programming the PIC for car black box, we need RTC of DS1307 for reading the time continuously to record the event, and there is a keypad which it was used for gear changing event, and finally time and event are displayed in the CLCD display with the help of programming. But all these events and timers are recorded in the WP-ROM. We are going to see about the simulation softwares, and I programmed in MPLAB codes. By programming in this MPLAB I created a project which it was named as a Jacket Car Black Box. I am just created a separate header files and source files for easy readable. These are the header files. The first thing is ADC, and this is the car black box definitions, CLCD, digital keypad, DS1307, which it is an RTC chip, and I2C, and main header files and timer header file. And also I created the source files which it makes separately. Same like as a header file, I created a separate source files for my project. Come on, let's get into this simulation. By default, it will displaying an event in a dashboard. By pressing an RB2, no, sorry, by pressing an RB1, I'm just increasing my event like gear 1, gear 2, gear 3 and gear 4. And pressing a RB2 switch, which is decreasing a gear. By pressing an RB0, which it makes the collision event. And then the RB3 key is pressed, the LCD is displayed, enter a password. My password is RB4, RB3, RB4 and RB3. By entering the correct password, we will get into the view log screen option or clear log option or change password. By navigating these options, we just using a RB5 switch, RB4 and RB3 switch, and selecting this option we used RB5 switch. I'm going to view log section. By pressing RB3 and entering the password again, and then I navigate to clear log section and select this, and I cleared successfully all the log events. And I navigate to the change password section by pressing RB5, and I entering the password like RB4 for the 4 times and re-enter, and again we just enter the password RB4 and the password changes successfully. This is my project, and special thanks to Managing Director of EMERTXE Training Institute of Moss Zukaku and Director of EMERTXE Training Institute of Jayakumar Balasubramaniam and Technical Head of EMERTXE Training Institute Mubin J. And also special thanks to Rajani ma'am for giving an embedded system training. Thank you all.